Okay, class, where we are now, this is what I want you to do. In my website, I'm gonna have three things you can look at. You want to take this list here. This is called the muscle list for lab. The muscle, you can't see it up here, but the muscle list for lab. That's an MS Word document. It actually came from Professor Rose Shute, just like this, the bone list I used in my bone lab. So if you can print this out, and these would be the muscles these would be the only muscles I would ask you anything about. Okay, would be these here, muscles of the face and so forth. Okay. Now, in terms of PowerPoints, I have two PowerPoints. One is this one, the muscles of the body, that would be in my website. The muscles of the body is a much longer one. It's 129 slides. Okay, this is a more extensive one. The one I'm going to use in this video very quickly is going to be this one here, which is called Muscle Addendum PowerPoint. Muscle Addendum PowerPoint. And this one, I only have 57 slides. So in other words, because I brought it down to where we would only just where you'd only just glance at these. Now, really, you can do this on your own because you can go through the textbook or whatever. So this is really very straightforward to do. I just kind of helped you a little bit here, but I may not even identify all of these muscles. But so you can do that on your own. Okay, so let's get started real quickly here. All right, right here, skeletal muscles are arranged in fascicles, if you may recall, groups of skeletal muscle cells. Some fascicles are circular, okay? Some are convergent. It depends on the force, the pull direction. What is going to be your pull direction? What is it necessary as far as the pull direction in order to do this? So that determines how these fascicles are arranged, and you can look at that on different muscles. What I want to talk about very quickly is something called the lever system. Let me explain. The lever system basically is this, that your muscles are pulling on the bones at the joints. Your muscles are pulling on the bones at the joints. So in a lever system, what you're trying to do is to move something. Movement. The lever system has three generic components. The effort, that's really your muscle. That's the force. The fulcrum would be the joint. That's the pivot point. And the load is what you're trying to lift or whatever. All right. When you're dealing with a lever system, two things I bring up. You have a range of motion versus a mechanical advantage. A mechanical advantage means how much, by using the lever system, how much can you lift? Let me explain. Okay. You as a female, let's say a small female wants to lift a refrigerator. Okay. So you use a lever system. You're not strong enough to lift it. You use a lever system to try to lift it. And you can do it. You as a small female may be trying to change your tire in your car. Well, obviously you can't lift a car, but you could use a lever system. Now, the difference is the more the mechanical advantage, the less the range of motion. Like Archimedes said, give me a place to stand and a lever long enough and I'll move the world. Okay, see right there, this guy is standing right there. That's the lever, here's the world. But this length here, which we'll call the effort length, has to be real long. All right, so we go here real quickly and talk quickly about the lever system. All right, right here, this lever system here gives a mechanical advantage with a power lift. Now, this is the old-fashioned what? Jack for your car. You see how far, now on the calculation, it's really a physics, they do this in physics, a calculation. You always look at the fulcrum, always look at the fulcrum and measure how far the effort distance versus the load distance. The effort distance versus the load distance. All right. The further out the effort distance, the more mechanical advantage, but the less range of motion. See here, with a jack, you have to keep going up and down because you got a long lever and this is short. Okay. We go further. Here's this right here. Now let's look. Here's the fulcrum. See, the load is further away from the fulcrum than the effort. That means it's not much mechanical advantage, but it is a good range of motion if you can lift it, because all you have to do is push down that little bit and this thing's going to go up. See? All right, let's go further. So here's a first-class lever. A first-class lever, the fulcrum is in the middle, kind of like a seesaw. That's the most common. Here's the effort arm, and it's a little further away. Here's the load arm. See right there? Now, if this was a seesaw, it would be equally balanced because you and your partner would be doing the same thing. But anyway, here's what we're looking at. Effort, fulcrum. Okay. Here would be an example of that right here. See how you have this? That would be your sternocleidomastoid muscle. And in the head right here, this would be the occipital condyles on top of the superior articular facet of C1. Okay. Here's a second class lever. Now here's your fulcrum. Here's the effort far away from the fulcrum. Here's the load. See what I'm saying? Here's the load. Load is closer. Wheelbarrow type there. Okay. Now, in that particular case, so you can lift your body up. Second class lever. Okay, and here's a third class lever right there. Here's the fulcrum. See, the load is further away than this. That doesn't give you much mechanical advantage. Just like this here. You know, this is not easy to do at the gym. You got to be pretty strong. Okay. So that kind of gives an idea on the lever system. So I'm going to let that be. I'm going to close this one, and I'm going to say that this is Muscle Lab 1 levers. Muscle Lab 1 levers. That's going to be what I'm going to do with this one.